Okay, welcome everybody to Dallas Personal Robotics Group Ro- Robotics Builders Night Out. We're virtual right now. So we've got a queue of several people who want to update us on their projects and or share information. So let's get started. This is August 20,
Anuya. Oh,
August
sorry.
22nd, August 22nd, 2023. And Anua, go ahead. Uh,
So,
so everybody go ahead and pin her. Okay.
I think she's going to run a presentation.
Okay, that's fine.
I am going to run a presentation. Okay, so can you see my screen?
Sure can.
Okay, so as you may know, I'm Anuya Das and I'm part of Iron Rain, an FTC team. And so this is our presentation on our summer project. And last year, what we did was we tried to automate a mechavator, and this is just a teaser for that.
The most awesome project I've ever seen in DPRG, by the way.
And so this year we wanted to do something more applicable. And every year we try to have like a summer project where we can get newbies used to what Iron Rain is like, and we can get them used to like doing things which could be applicable in the real world. So we decided to automate a 18-ton RV called RV2.
I love it.
So that is what we're working on right now. And so because it's an 18-ton RV, we had to have a lot of safety requirements. And so the first things first, our professional safety operator, Mr. V, is always behind the wheel, and he can override all automated systems, including our braking, our steering, etc. And our braking system itself, it's constantly pushing down on the brakes, so you have to actively stop braking. So that is a mechanism we also have in place. And vehicle movement is generally kept to a walking pace by our PSO, Mr. V, which basically makes sure that it can't run over somebody in a dangerous way. And our driver's side airbag is deactivated, and we'll go over that when we talk about steering. And as always, all of the details for everything we've done on R2V2 is detailed in our blog, which will be linked in a later clip. And so this is our site. So basically, the little blue area you see is our coach's house, and it's significantly higher in elevation than the area in white, which is the RV's operational zone. And this is the only place the RV is allowed to operate, especially by remote control. And the yellow line represents points where the vehicle will be stopped by trees, undergrowth, or extreme slopes, and the red represents impassable uphill berms and cliffs. And this is a closed course, and there's no other vehicular traffic, so the only people we can be a damage to is ourselves. And these are just procedures that we have to maintain our safety as a team and to make sure that we are showing that we are taking all the precautions we could be taking. And once again, all of our precautions are linked on this blog post. And for development, so the entire point of this project is to show just how far you can take basic robotics materials. So we use the Rev Control Hub and Rev Expansion Hub that we use on every single one of our robots as well, except this time we are controlling the braking and steering of a RV. And so we have our safety design and procedures completed. Our braking system and steering system is also under control, and so is a remote teleop drive. We just haven't completed vision-based tracking and steering or GPS-based driving yet, but those are works in progresses that we are currently planning on doing. So these are the two main controls. We have our steering and we have our braking system. And our steering is controlled by a rev motor attached to a worm gear mounted on a plywood adapter for the steering wheel. And the paddle anchors the motor to gain enough torque so it doesn't rotate. And you can't see it, but the paddle is attached to the window of the RV. And the braking is controlled by a system of pulleys which are tensioned, so they try to remain in a pressed position constantly. And a string is pulling back on the brake pedal to release it, which allows the RV to move forward. And basically, this works as a fail-safe, so if the RV loses power, it will automatically return to a stationary position. And so for our steering wheel design, our first prototype was that we wanted to attach the sprocket and chain directly to the plywood, but we realized there was no convenient way to do that. And because we would have to use a chain and we'd have to attach the motor externally, the chain would twist possibly because of alternating motions, and we didn't want to take that risk because, once again, 16-ton RV. And then we also didn't know how to attach the plywood onto the steering wheel, and we wanted to make sure that we wouldn't do any permanent damage to the steering wheel, so we used straps to attach the steering wheel to the plywood, and it can be removed within seconds, so all of this is very impermanent and can be taken on and off really quickly if need be. And then we decided to use the worm gear and paddle attachment with the motor directly onto the plywood attachment for the steering wheel, and that's what we stuck to. And this is how our assembly works. We use carbon fiber plates to attach the plywood steering wheel attachment to the worm gearbox, which then attaches to the paddle. And we use a REV ultraplanetary motor to control this whole thing. And the reason the driver...
Should we ask questions as you go through, or should we hold them till the end?
That's fine. How are you like?
Okay, I was just wondering if maybe you're going to go there, but on this last one you talked about the worm gear, which can't be back driven, and so I'm wondering how the safety operator override would work, because it can't back drive the motor.
Actually, I'm pretty sure this worm gear is back drivable. We discovered it while we were testing, conveniently.
It's only a 10-to-1 worm gear, and depending upon the architecture of the arrangement, some of them are back drivable. It typically only happens with very low gear ratios, and a 10-to-1 is low for a worm gear. But if the quality of the components are high enough and the incident angles of the gears are correct, you can back drive them, and this one can be back driven. Although the total gear ratio, I think it's about 200-to-1 when you add up the planetary gears plus the worm gear. So it takes a lot of torque to back drive it, but it does move.
How did you figure out the what torque you needed? Did you use like a spring scale and pull on it to try to get the steering wheel to rotate or something?
Honestly, it was generally trial and error, trying to figure out what configurations would work to get the steering wheel to move, because it's very heavy. And we also needed to make sure the way we attached it to the plywood wouldn't move, because we're using shaft collars, if you can see them, to attach the entire assembly onto the plywood, and we just constantly tightened them to make sure we had enough force, if that makes sense.
So I did let them early on in sort of the exploratory phase. I turned on the engine so that the steering assist was active, and let them get a feel for how much pressure it takes. And they've got some experience with how much torque these motors can put out in different configurations. This is the highest gear ratio I think they've ever gone to, but I think they stepped it back down from the maximum. At one point they were dealing with a 600-to-1 gear ratio, and we use these motors that have stackable planetary stages, and so you can take out one stage and drastically change the whole configuration. And so they took out one stage, and it was still enough to turn it when the engine was on, but if the engine is off, it's not strong enough to force the wheels.
Yeah.
Yeah,
I imagine the kind of what I found with the lawnmower. I had a linear actuator pulling and pushing just a rod that I had welded onto one of the, I don't know if it's a knuckle or what the joint is called. It's kind of like an L, a rod that's in the shape of an L. The tires on the horizontal portion of the rod, and then the vertical part, is what bears the weight. But I found that the linear actuator moved a little bit too slow, or slower than I would have liked. So if I was turning, I had to go at slower speeds to get the amount of turning that I needed. Otherwise, there were these big gradual turns that I didn't feel like I had that much control. It's kind of like, okay, it's turning, but you know. Oh, and the other thing is the picture of your that block there. That looks like what's known as a rag joint on older vehicles. It actually looks like somebody took a piece of tire and poked 4 holes in it, and 2 holes went to the steering box and the other 2 went to the steering column, and it acted as a kind of a flexible joint, you know, between the 2, because the column could come down at a different angle than you know, the top of the steering box was at.
Are you talking about the rightmost picture?
Yeah. Yeah.
Yeah, that's actually rigid. That's a carbon fiber plate.
Oh, it is. Okay.
Yeah.
Yeah, it looks like a rag joint though.
Yeah, it kind of does, but it's not. It's rigid.
Okay.
The basically the whole steering assembly is mounted on the steering column, right? And all that paddle's trying to do is prevent it from rotating.
Yeah.
So it can be it doesn't have to be flexible. It's going to stay whatever orientation the steering column is giving it.
Yeah.
Well,
so you haven't broken a window yet with the paddle, huh?
Not yet. It's sticking out the window, actually.
Oh, it's sticking out the window.
You should cut it down. You should definitely cut it down.
Yeah.
I'm, you know, I've watched Iron Rain make a lot of robots, and I'm a little surprised that. So, like in this design, you know, the motor's right in the center of the wheel, and so you're having to have a lot of torque. And I know that in the past I've watched you make a lot of turrets, and I'm surprised that you didn't have like an internal ring gear around closer to the edge of the diameter of the steering wheel, and then, you know, have the motor mounted so that it was running in that ring gear, which would take a lot less torque because it'd have the big moment from the center until the edge of the wheel, just like when you're driving. You know, you remember in the old cars before power assist, the wheels were like big. So
that was the original intention. The first design, that one shows a very small sprocket. That was just for initial testing. Their plan for that center sprocket was to be a pretty big sprocket,
okay.
And then that would have done what you're talking about. But so there's probably more stress than we want on that plywood connection.
Yeah.
I guess because the screws there, I think something like 16 millimeters out radius out.
Mm-hmm.
And so there's a lot of there is a lot of force there, but it's not more force than the motor can output. So even with that 200-to-1 ratio, it appears to be strong enough. Again, this is like an early go. I don't know how much we're going to evolve on this. This is like a short-term project. So.
Yeah, I was just saying, I know you guys have a lot of experience in turrets and that sort of stuff. I was just a little surprised that you were doing it with a center of the wheel drive. I guess
this is a remarkably stout gearbox for that final 10-to-1 reduction. Yeah. It's a very, very stout gearbox.
Boy, guys, this is ringing so true, because when I was working on the Army trucks, we would pull out the whole original steering wheel and column and replace it with a TRW column, and then bolt the steering wheel back onto it. And the TRW column had a motor that drove the shaft and had sensing between the force coming back from the wheel, from the steering gear, and what the operator was applying to it. And we measured the force to make sure that the smallest possible operator would be able to overdrive the motor. This is all just ringing so true.
We just physically countered it and experimented. So the one thing we don't have is the feedback from the self-centering. We have no idea what the road pressure is coming back against the system, but we can tell I think it's coming up in the presentation, but we can tell the amperage draw on the motor, and so that tells us sort of pretty. In fact, we're using that to do our calibration. Is the calibration side in here, Anuya?
Yes, it is.
Okay.
Okay, I guess I have one other question too. So there's no attempt to disengage the gearbox. There's no clutch or anything, so they'll allow the operator to take completely over with no resistance, right?
Did you leave in the safety slides about the? I can't. It looks like we. Let's hold that question because I think the answer might be coming up.
Okay, cool.
If not, we'll address it then.
Okay.
So we had to disable the driver's airbag because we could literally launch a triggered airbag into the PSO's face because of how heavy our steering automation assembly is. And this is our steering calibration.
That's before we put it out the window. This is an earlier test.
Is this with the van sitting still? You're turning.
Yes.
Whoa.
Correct.
With no momentum to get you started. That's pretty cool.
That's correct. Yeah, it's just doing it on dry pavement.
Yeah.
Wow.
Wow.
And the pressure on my hand at that point isn't much. Way out there, I got a lot of leverage on it. I barely felt it.
Thank you. So there's steering, huh?
Exactly. So what it did is it went all the way to the right first, I think, and then all the way to the left, and it just looked for a stall condition to determine when it was at the end, and then it snapped the encoder positions at those points, zeroed them so that it went back to center, and then zeroed it at that point. So we have odometry on the steering wheel, basically.
Cool.
Yeah, I don't know how tight the front end of your RV is, but I have a small van, and it needs pretty much the front end gone through. All the ball joints are a little loose. The pitman arm, it moves like a quarter of an inch, and you think, a quarter of an inch, that's not much. But, when it comes back to the steering wheel, the thing will drift several feet left or right all on its own without you moving the steering wheel.
Well, it's an old vehicle. It's a 98, but it's only got about 40,000 miles on it.
Yeah. Yep.
Go ahead, Anuya.
So the next part is our braking, and so this was our initial design, and we wanted to use multiple pulley systems to manipulate both the brake and the gas pedals, but we decided to first focus on braking because we needed to make sure the brake always stays pressed in case of loss of power connection, just as a failsafe. And we realized that if we wanted to have multiple pulley systems, at least the way we were planning on doing it, it'd be a really large system and would be a really long installation and removal process. And we needed to make sure that we could install and remove it quickly so it would be regularly drivable as well. So we settled on a pedal mechanism that would act as a foot for the brake pedal, and you'd have bungees which would actively pull the pedal down. And this is entirely slotted beneath the seat and steering wheel with really fast installation and removal. And so we used a rev rail frame and a pedal mechanism pulled down by two bungees, as you can see. And then we had it rotating on an axle and the pulley system being controlled by a geared motor. And then because we needed to make sure the string had enough strength to lift the pedal fully, we used an elevated pathway to assist the string. And you can see the pedal where the brake will be pressing down. And this is the R2V2 in action.
So it's actually under the control of one of the students there. I'm in the driver's seat. It's hard to tell. He's in the passenger seat steering the vehicle. And yes, it does. The turning speed is too slow of the
is it?
Of the steering wheel. Yeah, we need a beefier motor in there.
Yep.
So we don't have a whole lot of example video of that. It's just the one scene. We haven't compiled a video yet of all of our different fragments. So
It's a work in progress.
yeah, that's what we had for Saturday's presentation.
And here are just some of our future plans. We want to improve the passive braking strength because we need to constantly retie those bungees, and we want more control, and we also want to beef up the steering motor so it's more responsive, because the speed at which it was going and how much it was turning, that was with the joystick that controls turning pushed up fully. And we want to use vision-based tracking similarly to what we use on our robot. And we want to be able to track objects, specifically a human in a traffic cone costume. And we want to have precise GPS waypoint following. We did this on Mechavator, and we want to do this so we could completely automate this process so we won't even need a remote control on it. And we want to test on larger closed courses because, once again, we're literally testing in our coach's backyard. And we want to be able to see just how far we can take this. And because this is entirely made to work both remote control or completely automatically, we want to work with mobility assist companies to see where our ideas could be properly implemented. Thank you.
It's pretty cool.
That is so awesome. I love that.
Yes, very nice. Very nice.
This is awesome. Yeah, very inspiring.
Yeah. I guess
So you said a practical use of two excavators jousting. Is there a practical use of two excavators jousting?
We can say the things we learned in the process of building excavators that can joust are very applicable in the real world.
Okay.
That's a nice twist. Yeah, nice spin. Doug, I think the slide. I've forgotten what your question was, but I think the slide was not in there that would have answered it. Do you remember what your question was?
Yeah, it was. I was just wondering if you had a clutch in the
Oh,
steering.
David, missed the whole thing.
In the steering area that would allow you to like push a kill button and the clutch would open, and that would just totally disconnect that heavy ratio motor, so it would be easier for the operator to take control. And I just wondered if you guys had thought about that.
So yes, the answer is no. So yeah, we took out that slide, but the whole the way we're thinking about it was steering was not our safety system. Stopping the vehicle was our safety system.
Gotcha.
Because there are going to be so many different. So yes, as an operator, I could make decisions about which way to steer, and we might look at that in the future. But since in these parameters, we were never going to go about more than 5 miles an hour, all we had to do was stop, right?
Yeah.
And that would take effect faster than any kind of steering input.
Yeah.
So we're on a closed course, nobody around, only going 5 miles an hour. Safety is just to stop the vehicle.
Yeah, you guys missed last week. Ted, Ted was part of the autonomous car that ran at Spark Funds AVC, and I can't remember what year it was, Ted, but he showed that. Would you guys be interested in seeing that?
Yeah, I think that was 2 weeks ago.
Oh, okay, you have
Yeah,
seen it.
something like that.
I saw it. I don't
Okay,
think that
okay.
I showed it to the team.
Okay, well, I
It would be
don't know.
great. It'd be great to see that again. So go ahead, Anuya.
I'm so sorry. I have to head out, but
Sure.
thank you so much for having me and listening to our presentation on one of our crazy summer adventures.
That was awesome. Thank you.
Yeah.
Very good.
Yeah.
Do they get a gold star?
Yes,
At
that's
least
well,
it moved.
well, they
Yeah.
showed it
It
moved. Yeah, you get a
Yep.
gold star. Okay, Iron Rain gets gold star. Very good.
Hey, Ted, what did you use for steering motor on that?
Yeah, I'm trying to remember. It was a number of years ago, but yeah, it escapes me.
Okay.
I know
Well,
at one
these-
point we we're experimenting with someone had some really heavy duty servo motors, like really big beefy ones. We might have used that. I don't remember if it wasn't enough. I know we had some sort. Yeah, it was a chain drive, I believe.
Yeah, I think I saw a chain drive in your video 2 weeks ago.
Yeah.
Yep.
While you're looking that up, so there was another slide that was missing. Basically, there's also a big red emergency stop button on the console right next to the driver. So I hit that, and all that does is disconnect power from the entire control system. And then the bungees take over. The steering tends to self-center if it's moving at all. But again, our whole concept is just it jams on the brakes because the bungees are, yeah, like that. Yep, exactly like that. Although ours is cheaper, it's plastic.
Yeah, did you want me to show that video again now?
No, well, I
That's up
didn't
to
know
Doug.
if Kareem has already seen it. I think that's fine.
I've seen it, and I knew you had to leave. So,
But what would be nice, Ted, is if you could. I don't know if
A
you
link.
did it. Did
Yeah,
you do the link?
I'll post the link here.
Yeah, if you post the link, that will allow Iron Rain, if they want to take a look at it, see how other people have done it. Yeah. Okay.
thanks.
Boy, there's so many similarities in concept between what I did at Lockheed Martin on the self-driving trucks and what you guys were doing with the emergency stop button, disconnecting everything, and steering being secondary, but brakes and stopping the vehicle being primary. One of the big differences I think would be the throttle and brake.
Budget.
Throttle, well, yeah, budget. They could afford me.
Yeah, you had the throttle going, right?
Well, we'd use the CAN bus, put messages on the CAN bus to tell the diesel what how to run the throttle, and we'd actually cut into the airlines for the brakes and drive them ourselves. But like you guys did, it was all fail-safe in that a power loss would return to manual control, and we had a big red button that the operator could push to disconnect computer control. But so many conceptual similarities. I mean, and the GP waypoint following and fiducial following. I mean, this is just like right up there with what we were trying to do with those army trucks.
We probably did one thing better than y'all. One thing.
Okay.
I made it a requirement that they had to be able to install it and rip it back out again in 5 minutes.
Definitely.
And
Definitely.
and we can do that. We can take the whole thing out in 5 minutes, install it in 5 minutes. Yeah.
Yeah, I think ours took like half an hour or so. So
Mm-hmm.
you were a lot faster. And Ray, I just looked it up, and it was a servo motor with the chain drive.
Yeah.
Awesome project, Kareem. Hats off to you and your team.
They have a lot of fun with these kinds of learning opportunities. So yeah, it was a good project. We still got a few more things that we want to get accomplished, but our season starts up again on September 9th, I think, and so it's coming up soon.
And I love the name R2V2.
Yeah.
Kind of had to do it, yeah.
Well, Kareem, do all
That
these
was-
things still get built in your house?
Yep. We were never able to launch the whole workshop thing, but you know, that might still be a future thing. That's the lot that where we're driving it was we had a plan to build a workshop there, and hopefully we'll get around to that sometime. But right now it's just a field of weeds, but fairly flat. So helpful, but we can only go about 50 feet. So that's why we're looking for some other closed course where we could, that people wouldn't be totally freaked out by us testing the vehicle there.
Well, it seems like when I was out at your place a couple of years ago, you had front loader or a backhoe or something that you guys had wired up to your remote control?
Oh yeah, that was last year's project, and yeah, it was an excavator.
Excavator.
Yeah,
Scary.
yeah, we showed a little bit of video of that earlier in the
Awesome.
presentation,
Just
but
awesome.
yeah.
Well, Ray,
This one,
excuse me.
I'm just saying that this one was just slightly bigger than that one,
Yeah.
but in many ways simpler, right?
Heavy.
But technically more risky in that, you know, the excavator could never go above about 5 miles an hour, 4, you know, actually, and so, you know, this one, you know, can hit 90. I know it can hit 90.
Oh, dear.
You shouldn't know that.
Okay.
Ray, what did you end up using for steering on your lawnmower?
On the lawnmower, it was a linear actuator, similar to.
Does it have torque specs?
Not as long as this one, but similar, about half the length. And it, I'm not certain what it's called. It's like it's a rod that has a 90-degree angle bend in it, and the front tires sit on the horizontal portion, and the vertical portion sits in a bushing. So it's like part of the suspension of the front of the mower.
I see
that
actuator.
bar actually pivots in the middle. So
We were using those same kinds for the excavator last year to operate the foot pedals.
That's what I
Oh, these things, yeah.
Yeah.
Okay, well, Paul, you were next in queue. Go ahead, and you were going to mention that.
Yeah.
Oh yeah, I did find something that I think would work a little bit better. They're actually, it's a go-kart steering mechanism, and it's a rack and pinion. So, you know, with a decent sized sprocket on the end of the steering shaft, you can, you know, pretty easily turn it without any issues. So I think I don't have one yet. The other thing that I wanted to try was
All right, let's let Paul go. You're next.
Okay.
You're next.
All right.
Okay, go ahead, Paul.
Yeah, so this just came across my newsfeed a couple of days ago, and I thought, oh wow, that's really awesome. It's really a new, I'm going to call it a new generation of LiDAR, not productized yet, but being developed by apparently a number of companies for the automotive market. And
oh, excuse me, is this what you posted about earlier today?
yes, it is. And so I thought I'd just show a little more about it, maybe explain a little more, and then just throw out questions. And I don't know any more than is in the article. So if you've read the article and understood it, then you know as much as I do.
Well, let's say read the article and stop at the understood it part.
Well, I stopped at the understood part to a fair degree too, but I think there was some good technical explanations in some of the links that you could find about how some of the stuff works, which I thought was interesting, and I thought I'd maybe include that.
Were they using some of the same technology that you see in TI's DLP projectors, chips?
No, I believe
No.
the DLP projector chips are basically a micro mirror that pops up and down
Yeah.
to reflect light.
I actually worked on those for a little bit. Yeah,
Or filter.
they can be tilted left, they can be tilted right, or they can be flat.
Yeah. No, this is completely different principles. It has no relation to that whatsoever, nor does it have any relationship to the principles of operation of the ST Micro 53 LCX family and the corresponding Broadcom family. It's really what it really amounts to, in my mind, is taking radar techniques and applying them to LiDAR, which is pretty stupendous, I think. And the benefits that they claim for that are that LiDAR has much higher resolution than radar because the wavelength is of the order of a micrometer, so high infrared, versus radar, which is in the millimeter, several millimeter wavelength range. So reflections and spot size can be much smaller in the LiDAR case. So just to orient you before I start playing this video, this is a video and the corresponding depth map. And just to give you the kind of scale here, these little dots, can you see where my pointer is circling here?
Yes.
Yeah.
Oh,
Okay,
yeah.
so those dots there that sort of look like people correspond to these people here crossing the sidewalk. And you can kind of see the front of a truck here that is this.
Mm-hmm.
And so when cars come by real close, they're going to come like right in here in this range. So all the action that you'll see in the video is going to be kind of inbound of this. Also, you're going to see this technique provides the Doppler shift owing to moving targets as a part of its output. And you're going to see vehicles turn this corner and head down the street, turn kind of a browny red color, and vehicles coming this way and then turning towards the camera turn a blue color, signifying the difference in coming and going. So I'll play it through a little bit at a time and point out some pretty cool stuff as it goes. So you can see these really do look like people here walking across the sidewalk. So that it shows off the resolution of the LiDAR system. Now, I think cars, the roof,
Oh, yeah.
let me just back that up because I believe that the camera and the LiDAR are mounted high enough above the ground that they miss the roof of some cars. And you can see that happen.
Hey, Paul, can you go over to settings and slow it down?
.5?
Well, let's give it a shot. Yeah. That way we can kind of watch it a little.
Good idea, yeah.
Thank you.
Oh, there it is. There's the roof of that car, I believe. Now, this one I think gets completely missed. The white car is that one. Then there's the roof of the Jeep just going by. There's a brown signal from a car turning away. Okay, let me back up and play that even slower because there's a lot going on here.
They picked up the white minivan pretty
Yes.
well, and it's like right down in that anchor point.
Yes.
Down by
I
the
think the
order.
white minivan is taller.
So is this a traditional type of unit? I mean, they're not even at test silicon yet with
It's
this
the
new
roof
system.
of the black car. There's the white car, and there's the roof of the black car passing near us.
I wonder if they need to point it down a little.
Yeah,
There's a
and there's
minivan.
some cars
Wait,
coming into that street. Boston Cab Association, so it was filmed in Boston apparently.
You know, you run into trouble when you point things down because you start getting reflections off the ground.
Yeah.
Which I assume is what those little blue spots real close are.
Yeah, they just seem to be noise as best
Yeah. Mm-hmm.
I can tell.
Canadian smoke particles.
Making clear. I mean, it even looks like a car.
Mm-hmm.
You're right though, David. They've cut out the ground, and they may have done ground slicing to do that.
Hmm.
so which version? Do you know which style of lidar this is?
I'll go into that here in a little bit because I think that's part of what's really new, because it's very different than anything you've seen.
But this is a traditional lidar, right?
No.
What we're looking at right now?
It's really quite different. I'll give
No,
me a
I'm
minute.
saying this actual video. Is this the new version or is this a traditional lidar
No, this is the new-
scanning?
This is the new version.
Oh,
the
really?
IEEE.
Can, can you play that again? The blue car coming toward us and the red one going away was really cool.
Yeah.
Where?
Oh, somewhere along in there. Yeah. See that car? There's a blue one headed toward us and a red one just turning the corner, moving away from us.
Hmm.
Oh yeah. Red on the image because it's moving away.
Yes, yeah. I'm sorry. I didn't mean a red car.
Yeah.
But you say, isn't that backward the way it's supposed to be? You know, red coming toward blue.
No, red shift is because the galaxies are flying away from us.
Oh yeah, right. Yeah, here's this one that's starting to go red as it moves away. That's
Very different. And this one quite blue in the middle there.
Yeah, I think that's the white car that's turning out of the side street.
Yeah, they're right
I
next
totally
to
missed
each other.
that Jeep.
So this is it's worth noting that this technique gives you a difference in velocity between objects that have a narrow angular separation from one another, but are traveling at quite different velocities. So you can imagine that would be very useful in self-driving kinds of applications.
So you said it's not a SPAD like sensor array or
No.
Totally different.
Totally different.
Well,
I'll
you're
go
going to show us how.
And there's the pedestrian. I mean, you can see their arms. They're even like the resolution of this is really something. I mean, you don't see this kind of resolution out of like one of those spinning coffee can Velodynes. And here's the blue from the white car that's turning right, or silver car, I guess, and the white car just behind it.
Well, and you know, it's a lot more to hit the moving dots that are people, you know. So
It's a lot what?
a lot more expensive if you hit the moving dots that represent people, you know.
Yeah, right. Okay, so there are two techniques that they've introduced in this LiDAR sensor that were born in radar and have been imported into LiDAR, which is like, I think it's just dramatic. One is beam steering, which they do in the optical domain, and the other is chirping, frequency, continuous wave. I forgot the name for modulated. modulated frequency modulated continuous wave. So this animation here shows how a phased array antenna works, and how it works to perform beam steering. And so the emitters sequentially emit a wave, and so the wave ends up time delayed as you step down the array, the linear array of emitters, and the net of that is to produce overlapping wave patterns, some of which reinforce and some of which cancel. And they and what they're trying to depict here with these kind of like fireworks streamers coming out is that's very low energy, so not much is going to get reflected back off of it. But you can see there's a strengthened main beam that's going off at about a 30-degree angle to the left. And it happens as a result of delaying the emitter, the signal coming out of the emitter, as you go down the length of an array. And they do this in 2 dimensions. And the Starlink antenna does the same thing to steer the beam around the sky and chase satellites across the sky. You have a 2-dimensional array of these emitters or receivers, and receivers, and you phase shift both in the X and Y dimension of the antenna array, and you end up with a steered beam. And there's
isn't there something else going on here? I'm a little fuzzy on all this myself, but I've seen demonstrations of this in a wave tank. And the point that they were making was that it's not just that these are out of time sync with each other, but rather that you have sum and differences of the waveforms. And those sums and differences are what causes the beam. Am I totally off base here?
No, what you said is correct. Both are true.
Yeah, but I got something that might help. So if you look at those guys, you can see there is a very similar curved line coming out. And if you look at it as it disappears, those lines keep getting longer. But what that really represents is the signal. Each one of those little curved lines is a signal from the individual emitter. So as you can see, they kind of reinforce the back there, and you end up with like a wave front, but each individual wave is actually an arc. I don't know if that helps any.
That's exactly right, Doug. And what David said is correct also, because the arcs are adding to each other along the wavefront,
right,
and subtracting from each other where the streamers are coming out.
Yep.
So is this radar at this point, or is this actually done with radio waves or with light?
So the sensor that I'm describing here does it with light, and that's what's new. It's a well-known technique to do with used with radio waves in everything from radar to both automotive radar, military radar, and Starlink communication systems. Wherever you have to point a beam, this array of antennas is a well-known technique. And the emitters are only about a wavelength apart. So in millimeter radar, you can have little dipoles printed on a circuit board that are a millimeter or a couple of millimeters apart, and fairly easy to build. But they're dealing with micrometer wavelengths here. So these emitters on this new sensor are actually only about 1.5 micrometers apart, and so they're built on a CMOS chip using conventional CMOS photonic techniques.
Paul, you said the receivers were micromillimeters apart. Did you mean the transmitters?
I'm sorry. Both the transmitters and the receivers are about 1.5 micrometer apart. About a wavelength, and so if they're using 1.5, if they're using 1500 nanometer, which is 1.5 micrometers, near infrared, then the antennas apparently, I think they're supposed to be a wavelength or a submultiple of a wavelength apart, but I don't understand enough about this to be confident in that. But what's feeding these in this antenna? These are emitters, and there's waveguides behind them, and electrically controlled delay. I'll call them silicon delay segments in the path to each emitter. And then there's a single LiDAR source feeding all of this. So the LiDAR source, imagine it coming up from the bottom of the page here, goes through a bunch of beam splitters that splits it into some thousands of beams that then are piped through a waveguide into a piece of silicon which can have a voltage applied to it that causes light to travel more slowly through it. And if it travels more slowly, then it's going to emit the wavefront later. So it is actually a single wavefront coming from the master laser, split into all these beams, and then
otherwise you're trying to align wavelengths of light, which I imagine would be pretty tough.
Yes, exactly. That's one of the points I'm trying to make, is that this almost has to be done on a chip, because given that the wavelength of light at that near infrared is about a micrometer, they're dealing with insanely high tolerances on the precision of manufacturing. And so using CMOS technology to manufacture this all on a chip just makes more sense, just makes so much sense. We've got a couple of other phased array graphics just to maybe give a different sort of like look at it than this, but I sort of like this because you can see the emitters pulsing out their wavelength one after the other, and you can see, as Doug observed, that each of these arcs is coming from the emitter directly below it, and that they reinforce on an angled plane. And again, bear in mind that this can be two-dimensional. So here's kind of the same picture from Starlink. This is a description of how Starlink works. And it's kind of the same picture. They've got multiple emitters emitting a delayed wavefront, which ends up combining on a wavefront that's angled to the plane of the antenna array. And this is yet another graphic. This one seems to be using dipole antennas because it's bidirectional. It's got two lobes, one out opposite ends. But if you just focus on the left hand, haven't figured out what the right hand one means. This is the wave, the signal strength pattern emitted by 7 antennas, and the left one, the antennas are separated by the wavelength divided by 2. The right one that I haven't figured out, wavelength divided by 4. So, and then up top is the relative phase difference between the 7 antennas. So I'm going to start playing it from scratch and notice that when the phase difference is low, like 3 degrees, you've got a top and a bottom lobe and a couple of side lobes. So all of the energy is in coming out of 2 lobes opposite each other. As the phase difference increases, the lobes rotate, and you've actually got summation and cancellation going on here to produce these lobes, to your point, David, until eventually you reach a point where they're rotated 90 degrees, and then as you carry on through the rest of the arc, you end up back at 360 degrees with 2 lobes.
Maybe it's just me, but that's easier to understand.
Okay.
Somewhere on the internet, I saw a few years ago a guy demonstrating phased arrays, and he had a bunch of relays, and he just had them in a tub of water. And by firing them off in different orders, you could really see the waves in the tub of water. Yeah, you guys might want to Google it. I just looked, I couldn't find it. The other question I asked, since you compared this to industrial LiDAR, which typically start at like $2,000, is that similar for this device?
Okay, so the industrial LiDARs that you're talking about, the $2,000 would be line scanning.
Right.
So 1-dimensional, not 2-dimensional.
Right.
And
like the gadgets on the self-driving cars.
Right.
The article.
That's the coffee cans you were talking about.
Yeah, the article that Paul said that they're planning major sampling in 2025 when they're targeting the car market at $500 a unit.
Yeah.
Of course, the car market, big market.
Yeah.
But I'm like Homer Simpson. 2 years, but I want it now.
This sequence of images here, the blue is trying to represent cancellation, and the green and red is trying to represent addition of the waves, and how that happens in a phased array. So yeah, what you said, David, addition and subtraction, and that's caused by the phasing of the signals out of the different antennas.
And basically, as you're describing, they're doing that optically.
Yes, exactly. So let me skim forward now to models of what they think the thing will look like. So these are a couple of models of what they imagine it looking like, renderings. 2 models of it, a long range narrow beam one on the left and a short range wide field of view one on the right. And it's just basically arrays of emitters. And and this is a prototype that they've got in a box at the moment, that presumably is what they used to make that video. And so this phased array, to steer it, and doing that with light I'd never seen that before. So as far as I know, it's like new technology. It's an old well-known application using phased arrays, but to do it with light, I've never seen that before.
So they talk about how long it takes to scan, to go through the scan, to scan an image with that sensor. Is it like, frame rates is like video frame rates, or
much faster? They talk about a megahertz kind of scan time.
Whew.
Yeah, really fast. They say that they typically use wavelengths between 905 and 1550 nanometers.
Yeah.
Okay. So that's the steerable, electronically steered beam aspect of it. And I have worked with electronically steered radars. We had a Delphi unit on the Army trucks that electronically steered its beam and had a flat face, kind of like the picture that you saw, except there was like a whole array of little radar antennas behind it. Well, this is a whole array of LiDAR emitters and LiDAR receivers that make the steering beam work. And just to give you a feel for how much this amplifies or how much gain the steered beam induces compared to your pulsed LiDAR, where you've got like a spinning coffee can and the LiDAR beam goes out, hits something, and then you got time of flight until it's received by a reflector. The Starlink article says you can get about 3,500 times amplification by focusing the beam so narrowly using these beam steering techniques. So it makes it hugely more sensitive and also more resilient to ambient light, like sunlight, compared to traditional LiDARs, LiDAR spots reflecting off of a rotating mirror. So is there any more discussion on the phased array aspect?
No, I think we got it.
No, just give me one.
Yeah.
Yeah, right.
Claim you work for GM and say you need some samples.
Yeah.
I need two. I need both the long range and the close in.
Yeah, there you go.
Yeah. Oh, one more thing before I leave this slide. So apparently, the text describes how behind each of these emitters is a layer of silicon which they apply a voltage to make it cause light to travel more slowly through that segment of the light path. And then prior to that in the path, you've got waveguides and splitters that split the beam from the single LiDAR source into one for each of these emitters. And
so you have thousands of emitters and you have thousands of, what do you call this intermediate stage where it slows the light down?
I think they're called phase delay modules. Let me just see if I can find a name for it. I don't remember the name they use.
We need a name. The thingy that slows the light down.
Yeah.
It's probably just a light pipe that you know that what the velocity is of the light through it. So.
And how do you change that electrically?
Okay, there's a section on here on steering light with phased arrays, and they say that they're the only ones that have figured out how to do it electronically instead of mechanically scanning with mirrors. And
okay, can we call this? They use the term the photonic IC.
Yeah, that is the term that they use. Actually, I was about to say there's two ICs. There's the photonic IC that has the light paths on it and the phase delay segments, and then that gets coupled to a regular CMOS chip via some bumps, and the two sit face to face, and that allows them to use regular digital CMOS techniques to compute what the phase should be, and then drive that voltage onto the photonic chip. Apparently, they both use CMOS processors, but I have to imagine that there are all kinds of different compositions of layers in a photonic chip versus an electronic CMOS chip. So here's where they say you might wonder how all this optical phase shifting is done. It requires altering the optical properties of the transparent material inside the chip's many micrometer scale optical waveguides, which channel the light from the laser where it's generated to the aperture where it's emitted. If you can change the speed of light in that material, you'll alter the phase of the light exiting the waveguide.
Yeah.
And the material here is just silicon, which is transparent to light at infrared wavelengths.
Yeah.
And they
passes
talked
through
about
it.
a couple of ways of altering the speed of light. One is passing sound waves through it, being pursued by researchers at University of Washington. Another is to change its temperature. But what they don't tell you is how they do it. So that must be part of their secret sauce.
They do give us another term, though. Their thermo-optic, I've lost it.
Yeah, right here, thermo-optic phase shifters.
Phase shifters.
So phase shifters is what they are, but these ones are apparently electronically controlled. So they say with thousands of phase shifters on a chip, it's critical that each one consume mere microwatts. So you can't heat them up. And so they use electro-optic rather than thermo-optic phase shifters. So that's the key sentence right there, electro-optic phase shifters.
Electro-optic phase shifters, okay.
Yeah, whatever that means, that's what
That's really the piece that makes all this work. Though.
Yeah, that makes the beam steering work. There's another piece of it that I haven't got to yet, which is the chirp aspect, but I'll get to that in a minute. But here's where they say this approach enabled us to steer the beam faster, allowing it to step across a field of view at rates exceeding 1 million scan lines per second. So that's just astounding.
Mm-hmm.
And then here's where they talk about the chip, the flip chip, closely spaced optical waveguides, 1.5 micrometers apart, interfacing that to the electronics required to adjust the speed of light within them, and they use flip chip technology. One CMOS chip has thousands of solder-coated copper bumps placed about 75 micrometers apart, half the width of a human hair. So I guess that means 150 micrometers is the width of a human hair. So I guess that must be the pitch of the emitters. And that allows the silicon photonics chip to be permanently mated with semiconductor electronic chip containing the digital logic and the matching copper bumps. And then they use simple commands to the electronic chip that then drive the thousands of photonic components.
Pardon me if I say, what?
What are you saying what about, David?
What do these bumps do?
Oh, copper bumps or solder-coated bumps. It's a way of putting two chips face to face or stacking chips. And they can either stack them face to face, like topside to topside, or they can have through holes that go through the chip and have copper outlets with solder mating on the underneath of the chip.
I see. So the bumps are basically the mating connector.
Yeah, it's a mating connector.
It's like a ball grid array.
Exactly. It's like a ball grid array that joins onto another chip.
I got you.
Yeah. So the point here is that there's two chips here, an optical chip and electronic, more conventional electronic chip that are connected to one another via solder-coated copper bumps, and then they run the pair of them through a oven, and the solder melts, and then the two are permanently bonded.
The reason the bumps are needed is because there's thousands of them.
Yeah. Yeah, and then they run them through an oven, and the solder melts, and then the two chips are permanently bonded electrically and mechanically. So it's the same technology as ball grid arrays, as Ray said.
Yeah.
Okay. Any more discussion on beam steering? On the beam steering? If not, I'm going to move to the other unique aspect, which is the FMCW, frequency modulated continuous wave. So they say automotive LiDAR, so while more complex than time-of-flight-based systems, frequency-modulated continuous wave systems are more sensitive, essentially immune to interference, and can be used to measure the velocity of a target in addition to its distance. So there you have really, I think, the central pitch for this this sensor. I mean, yeah, it's great that you can steer the beam around and achieve high resolution, but what you get out of it is immune to it, is data that's immune to interference and can measure the velocity of the target in addition to its distance. I think that's a key sentence there. And so they say that automotive LiDAR is, FMCW LiDAR involves slightly altering the frequency and thus the wavelength of the transmitted light, and then combining the backscattered light with a local oscillator at the frequency of the transmitted light. And what they said before that is that they're chirping, so they're chirping the light, chirping in the sense of if the light was audio, it would go and so if the light was at, let's say, middle C when it was emitted, and the chirp keeps on raising its frequency and it gets up to D, E, and F before the reflection comes back, the reflection will be coming back at middle C. And so when you combine the reflection at middle C with the local copy of the transmitted signal, which is now at F in the audio domain, you get sum and difference frequencies via the heterodyning process. And that lets you tell that difference is proportional to the distance to the target that's reflecting the signal. Does that make sense?
Why does this sound strangely familiar to me? Frequency modulating a signal and then comparing it against the original to see what the phase shift is. One of you people with a better brain than mine, this is something I already know, but I can't remember why.
The only time, I don't know, I know it's been used in radar for a long time.
You know, there's an audio device called a ring modulator. That's used by punk bands, you know. I can't remember, but this whole concept of frequency modulating something and then comparing it to the original is something I've encountered before. I was sure one of you guys would say, "Oh, that's blah."
I don't know. I've met it in a total station. You know, a total station is one of those surveying instruments that has millimeter resolution over hundreds of meters. And I've met it there. That's the only place I've met it in the optical domain.
Well, maybe I've seen that before with the sort of things the field guys do, the geology field guys do. But I know I've run into this concept before.
Mm-hmm.
So that is combined with the beam steering here. It's not separate.
Yes. Well, the two work to achieve different things, right? The chirp and combining the local frequency versus a different frequency gives you range and Doppler, and the beam steering lets you scan the scene.
That, I think I remember where I've seen this before. It was in analyzing fidelity of audio recorders or the recording equipment.
Okay.
Where they frequency modulate the signal and then compare that against the original to see what the phase shift is, to tell you if the device is working. I think that's where I've seen it. All right, I'll shut up now.
So the other thing that I had not previously met was extracting Doppler shifts from a moving target, and they have a link here to a page that describes extracting the Doppler effect from in radar, and really they're doing the same thing just with light. And one of the things they don't talk about here is how they extract the sum and difference frequencies from mixing the reflected light with the emitted, with the local copy of the emitted light. But this page discusses modulation patterns, and I think what they're using here is triangular modulation, which allows easy separation of difference frequency, delta F, of the Doppler frequency, FD. So if you think about it, when you send light out to a stationary reflector, it comes back with the same frequency that it was emitted at. Now, skipping over the fact that they're chirping it, and so the transmitter is now emitting a different frequency, it comes back at the same frequency that it was emitted at. However, if the object is moving away from the emitter, it will come back with a lower frequency than it would have if the target was stationary. If the target is moving towards the emitter, the reflection will come back with a higher frequency, which obviously you maybe would think you'd get wrong ranges out of moving targets. But they show here how a triangularly modulated emitted signal produces a rising frequency and then a lowering frequency, and something funky that I haven't understood. I'll be honest, I have not understood this, but something different happens on the transition to a rising edge versus the transition to a falling edge that lets you tell what direction it's traveling in. And I don't understand more than that. But somehow there's something going on here that lets them separate out the frequency shift due to the Doppler effect by looking at the changes on the rising edge versus the falling edge. I sort of imagine it happening, because like if you've got a car coming towards you, and so it's at a certain range, but it seems closer because the frequency coming back is higher. No, it would seem further away because the frequency coming back the frequency difference is higher. But then when you start chirping downwards, you can imagine that the same car coming towards you, still the frequency is higher coming towards you, even though your frequency, the emitted frequency, is falling. So you can see that I can imagine the difference that would exist that allows you to use the upward chirp versus the downward chirp reflections to identify both what direction and how fast it's coming towards you or going away. So silence here. I think I've conveyed it about as well as I understand it, which is not very. So anyway, I think that's it.
Thanks.
It's like.
Thanks, Paul. That was really thorough, and it's new to me at least. I did find an article and posted a link in there from DF Robot, which discusses all the different types of LiDARs, and it includes this one, and it looks like there's about 4 or 5 companies working on this. So anyway, that might be something people can, if you don't know anything about LiDAR, that might be helpful to you. Okay, and let me break in. Let's see, who's next in line? Hey, Ray. Let me just throw a few things out real quick. No, go ahead, Ray. You go ahead, and when I get a chance, I'll just pull them out.
Okay. I have been working with an ESP32.
Mm-hmm.
It's the Vroom variant, and an MCP 23017, which is basically a port expander. And on Adafruit's website, they said that it's kind of weird, but if you happen to be looking at one of the ports as an input, and whatever signals on that port is transitioning, that it can hang up the I2C bus. And I had wondered if anybody else had experienced that with that part.
Not with that part. I've had that happen with one of the early LiDAR lights, though.
Oh, it would just hang up the I2C bus?
Well, something would happen, and the I2, it wasn't robust, and something would happen. And you'd be just hung up.
Really?
Yeah. So let me ask you. So do you have a link to where they talk about it? You said this was Adafruit,
I can look it
right?
up. It'll take a minute. It's on Adafruit's website, where they look at the MCP 23017, because she sells it, and now she has the same device with, much smaller, with quick connectors on either end, so you can string it along in a I2C chain. Anyway, yeah, she said the forums talked about it, and it's kind of weird. It's like, okay, with the ESP32, you can, and these two devices, the other device that I have on there, back up, it's one of the SDD 1306s. It's a 128 by 64 OLED display. It's, you can get them pretty cheap. They're pretty small. The common size for one is like 0.96 inches square. Anyway, so those are the two devices. I initially had it on the default pins, for I2C, and the port expander would always work. The OLED would sometimes work, but not very often. I put them on separate buses. That seemed to work okay. But now I'm back to the display not working. So it's just a weird flaky problem. I don't know if the MCP 23017 is the cause of it, or not, but I was just trying to hook up a simple LCD display to, I can present. It's a cell phone module board. It's based on the SIM 780G. I think I showed it to you guys last time.
Well, can you hook it up so that it's just the zoom and the display? Does that seem to work?
Well, I've tried it on, the two devices, because they have different addresses on one bus. I've tried them on two separate buses. The MCP 017 always seems to work, but the, for some reason the LCD just does not cooperate. I don't know what the heck is going on, but I'm using the examples from Random Nerd Tutorials, and his stuff is really good. And if I just have his code in there, it's probably some extraneous thing. Maybe I redefined a pin and stepped on the SDA or the clock or something. But um, and it's very flaky. It's like, you know, there's a couple different boards that I can use. There's one is the Node MCU 32S. That works for the part that I have. I can also use an ESP32 dev module. I don't know if the two are drastically different. So it may be, I don't know. I just wondered if anybody else had experienced that kind of thing with those parts, or with I2C buses hanging up like that.
This is where the logic, that little logic analyzer that
Would
we
come
talked
in
about,
handy.
you put that on there, and you just read what's coming over the bus,
Yeah,
and you'll find out really, really quick what's going wrong.
yeah.
So
The only problem is I don't have one of those.
Ray. Amazon, $7, no, $11. Well, I mean,
Yeah. How can you go wrong?
how can you go wrong?
Yeah. Probably should get one.
Yeah, I think so. I think everybody.
Anyway,
out
so
there,
there's a couple other there's simple LCD display devices, and this is one of them. I think this one's 7 segment digits, and you know, that actually would suffice. It's a fairly simple device. Even with the Arduino on board, it only takes like 40 milliamps to run the whole thing, and so I'm thinking if I can't figure out what my issue is with these devices, I'm going to slap this in there, because I'm tired of screwing around with it. But and there are some other devices that are super cheap, LED based, but I kind of like the and I think most of the current is for the backlight for the LCD, so I could turn that off and see if I can still see the digits, and I might just use that. So but
usually
anyway.
a lot of those boards have a control that you can set brightness.
Yeah. Yeah, this one has you can actually PWM there's an LCD pin, or sorry, LED pin for the backlight, and yeah, you can modulate brightness that way for the whole thing. So, but yeah, that's all I had. They're really nice little displays. You can get a lot of text on it. You know, there's 4 pins, power, ground, clock and data to them, you know, so they're, you know, pretty handy to use in very small systems and stuff like that. So
I guess the other question I would have, a couple of things, some ideas. Ray, this is out, like I say, the number one thing you need to do is go get the $11 logic analyzer and find out what's crapping out. Then but the next thing that there's, you know, I want to say it was Adafruits. I'd have to look at who made it, but the little terminator module that I put on all of my I2C buses, you know, that will cover up a lot of sounds. So that might be a possibility. And
Doug, when you say a terminator, is that just some resistors? What does it do?
No, it actually is an active. It boosts the signal. I think there's 2 types. One that I think just acts as a terminator, and then there's the active terminator one, which will extend the amount of your I2C bus for a lot further. And like I say, if I have more than one thing on there now, you know, when I bought them, I bought like 3 or 4 of them, and so I always have one I can just stick on the end, at least for testing, to make sure I've got no problem with it. Because that's the other thing too, and I'm not you know, a lot of times those modules might have their pull-up resistors on the module, and they might be buffered so that otherwise, like if you're going, they allow you to, if you think of it as on this side you got your module that's 3.3 volts. Well, what they do is they'll put 3.3 volt load up resistors and then a buffer. So then on this side you can have 5 volts pull up, and it won't screw up your 3 volt thing is properly level shifted. So, and Adafruit, if I remember right, is really good about doing that sort of stuff.
Mm-hmm.
So then the next question would be, does that display board have pull-up resistors on it? And if
I
it,
think it does.
yeah, I mean, I'm just throwing out ideas, you know.
Yeah.
The other idea is can you turn on your ESP32? Can you have a resistor added to your pull-up?
What do you mean? Can I?
Well, you know how you have an output, and then you have an output with an input with a resistor on it. What I'm trying to say is, if you're not using that, and the other guy doesn't have any pull-up resistors, it could be that guy just doesn't have any pull-up resistors. Okay, so I mean.
So I should add them.
Well, there's a couple of ways of doing that. You know, like I say, first of all, look and see if it's got pull-up resistors on the circuit board.
Yeah.
If it does, then that's probably not it. But if it doesn't have them on the display board, then you have to ask yourself, well, where is the pull-up resistor between the processor and the display?
Yeah.
So either you add them, you know, and something
Mm-hmm.
like just add 4.7 volts, 4.7K, 10,
Yeah.
between that and 10K between there, or you can have a weak one by turning on the resistor that's in the processor's output board. Yeah, like a pull-up.
Okay.
Yeah, exactly.
Yeah.
That's what I'm saying. So if you don't have them pull-ups, the pull-ups in your output of your processor, then a quick test, you have nothing to lose.
Yeah.
Just turn them on and
and
see if that helps.
Okay.
Okay. It might be just simple as, you know, putting one more parameter.
Yeah.
So, but that would tell you don't have any pull-up resistors. But go ahead, Ray. Spend the
What?
$11. Spend the $11.
Spend the $11. Huh?
Yeah, go get yourself your logic analyzer and help yourself out. Okay.
So what was that brand that you recommended?
Oh, I don't care. I usually go with the ones that have the cost the least. But I do like, you know, since I have plenty of DuPont connectors, I like to get the ones that have the little clippy poos.
Okay.
Yeah, you know, I'll pay $1 or $2 extra for the clips.
So was it it started with an S, right? The brand.
I think so.
Oh, you're the
I
Seiko?
think Kareem just posted a link to it.
Oh, did he? Okay,
Yeah,
let's
that's
see.
the Terminator extender active. So that, you know, that's
That's the
what-
Terminator, not
yeah,
the
yeah.
diagnostic board.
Well,
Uh,
Doug, I have a question out of my ignorance here. But if the device requires pull-ups, that suggests to me that what it's driving is going to pull that signal down, like an open collector or something like that.
Yeah.
Yeah.
And so if it's buffered, how does it pull it down?
Well, that's what I'm saying. If a lot of times, especially with the 3.3 or even funkier, you know, the 2.7, 1.8 chips, they don't want you to have to run your whole I2C bus at that voltage. So what they do is they put internal, on the little module, they put the pull-up resistors, and then they put a level shifter. All right. So on the other side of the level shifter, it'll pull up to whatever the VCC is on that side of the line. I'm sorry, David, you're muted. You're muted.
But then if I pull that line down on the other side of the
Well,
level,
ground will be ground.
okay, so this is an output that's being pulled up connected to an input that may or may not be pulled up. Is that right?
Yeah, I think so. I mean, otherwise on your module, on your display, it's going to be the input. So I guess the proper way to say it, yeah, it's an input. And, you know, some of them they can send across too. But, so if you look at the typical level shifters, there'll be, I'm just going to call it right side, left side, okay? So there'll be a left side VCC, and there'll be a right side VCC. If it's a 3.3 chip from Adafruit, it probably has that level shifter, and the right side VCC is tied to 3.3, which is what the chip expects.
I see, and they do that specifically so you can power everything else off 5 volts or whatever.
Yeah, and it won't kill that chip. Okay? You know, you can do it at you know, the ideal thing is to have the whole bus at the same voltage, which is 3.3, because now you don't have to think about, well, okay, this one's buffered and that one isn't buffered, and this one over here doesn't have nothing on it. You know what I'm saying? It can get confusing, and if you add too many unbuffered pull-up resistors, you know, they're all in parallel, so they get stronger and stronger, and that might not be what you want either. So it just depends, you know, like I got a feeling that Ray's got this cheap Chinese display that he picked up for $1.27, and I don't know how they handled the I2C bus. That's all I'm saying.
And I have to just say parenthetically that I've found over the years that when I work on a robot, that the thing that costs the most money is my time.
Oh yeah.
And it's not worthwhile trying to decide, should I use a $1 or a $5 part?
Well,
I mean,
I don't know.
If I was going to make thousands of them, maybe.
Yeah. Well, David, I don't know. I try to embrace. I hear what you're saying. I try to embrace the path, but but sometimes $1.27 is you know, I can't.
Awfully hard to resist.
Yeah.
Actually, the displays that Adafruit sells they're close to $20 now for that little 128 by 64.
Yeah. Well, I think the one I always
display.
ran into was their 16 server, their I2C 16 servo thingy, breakout board. You know, theirs is like you say $20. The other one is $1.37. You know, oh god.
These things are what we're talking about, right?
Yeah, I think so. It
know what
looks kind of
Yeah,
like it.
exactly.
Yeah. I got a bunch of them. I got a 5-pack for like $10 or something.
Yeah, that's what I'm saying.
And what I found on these is that I use the U8 GS thing, not the Adafruit controllers, and I had a better experience trying to get these. Well, I still haven't gotten that to work because I haven't transposed all the stuff, but it does work.
Yeah. There is a trick. You know, Adafruit has one nicety, and I can't remember what it is, but they do have a nicety on their board that the Chinese boards do not have.
I bet it's a voltage thing because this Chinese board here, it wants every bit of 5 volts to light itself up, even though it says it'll work off 3.3.
Yeah, but I'm just saying that there's something, and if you look at the boards and the schematics, you can see it, but you know it's still not enough. I use it, you know, almost every robot ends up with one of those somewhere. So so especially if it's an RC type car. So.
Well, I did buy recently, meaning a couple of years ago, a handful of level shifters for 3.3 to 5 volts.
Yeah.
Little tiny boards about that big.
Yeah.
And I thought, okay, this is going to solve all my problems. When I got them, I found out that you have to power them with 5 volts and 3.3 volts and send them ground and send them the signals. Pretty soon, this little tiny thing has grown to this big hairy monster.
Yeah.
And I decided I wanted to solve my problem some other way.
Yeah, but that's Dave. That's exactly what's put on the Adafruit boards.
Yeah.
So those two little MOSFETs that are on that board that you got, and
Yes.
they're already handling all the stuff on one side. So you only have to handle the ground, the VCC, and the two inputs, I2C inputs on
Well,
the other side.
What inspired this is, as you know, like 3 years ago, I started the process of moving the outdoor robot from the 68332, which is a 5 volt device, to the ARM, which is a 3.3 volt device. And among other things, I realized that my motor controller wasn't going to work anymore because I couldn't send it a full 5 volts, which the motor controller was requiring. And so I bought these to sit between those two. But what I found out since then is that the motor controller has got some little configuration switches on it. It can be controlled in a bunch of different ways. And one of those ways is the way I was doing it, which basically, 0 to 2.5 volts is reverse and 2.5 to 5 volts is forward.
Mm-hmm.
But you can also send it radio control pulses. And in that case, it's the length of the pulse and not its height that matters. And it turns out that the board will read those 3.3 volt RC type pulses. So that's going to be my solution if I ever get back to this.
Yeah.
I have to say that I think I mentioned to you guys at the time that my mother had moved in with us, and I really haven't done any roboting since then.
Yeah, it's tough.
It has been very tough.
Yeah.
But she is in a facility now, and it's better for everybody concerned.
Yeah.
She's
My
got nerve.
mother had to do that eventually.
It's a tough road to hoe.
Yeah.
But I mean that, well, like this evening, I'm here.
Yeah.
I know your pain, man. I do know your pain.
Yeah.
So I have a fun story to tell. Can I butt myself into your order here, Doug?
Sure.
Sure. You're on race time now, David.
I was pretty much done.
Okay.
We have got this coolest technology at work now. It bears a tiny bit on what Paul was talking about, which is evidently all over the world there's a lot of dark optical fiber laid down by the companies but never connected to anything. And we have an extremely expensive $250,000 device that sends signals down these and looks at the reflections. And we've hooked it up to dark fiber all over Dallas. And you can see all kinds of things. We ran an experiment. We just wound some of the fiber around a box and talked, and you can understand it. You can see seismic signals, you can see traffic, you can see the wind blow. It's the most astounding thing I've ever seen. We have the short limit of it. I'll get some screen dumps I can show you guys next time.
Okay.
We get 2 meter resolution, and it has to be at least 2 kilometers long. The couple of tests we ran, we had about 30 kilometers. And it's just an amazing technology. It just blows me away.
So what you're telling me is, David Anderson, what you're telling me is that the Batman movie where they turned every cell phone into a sonar thing, you just did that with dark fiber, and now we're scared to call?
Exactly. You can see at a given intersection, you can see the traffic, you can see the Doppler shift to know which way they're going. You can see the foot traffic of the pedestrians walking across the street. And as I said, we wound a bunch of it around a drum and talked, and you could hear conversation. You could make it out. And then you could hear the peals of laughter afterwards when we realized that it worked.
You know, I got a lot of colander hat wearing friends. I'm not going to tell them this story.
It's probably just as well. But it turns out that there's just this dark fiber everywhere. It's just everywhere. And all we got to do is go around and talk to the municipalities or whoever it is that's in charge and say, can we hook up and run some experiments? And it was started because the seismic signals are so, it's like you have this huge seismometer and it tells you not only where the earth is shaking, but all along the length of the thing. But it turns out you can see an amazing amount of stuff.
Is it called a time domain reflectometer?
Oh, I don't think so.
Oh.
Basically, my understanding is that every little ding, like when they go through a patch panel, causes reflections. And that when the seismic signals or whatever that disturbs, down at nanometer levels that disturbs the cable also acts like a kink and cause a reflection.
Yeah, there used to be a device that used to test fiber. You could find out, where the break was or pinch or whatever.
Maybe this is just the downstream version of that.
Yeah, and it was basically used to, tell guys where to dig and that kind of thing. So.
Well, I could tell that the people were really proud of it, not by just the cost, but by the fact that it came in this beautifully handcrafted wooden crate.
Oh, yeah.
So can you talk to the NSA over it?
Probably.
They're listening to you laughing.
Yeah, you're already talking to them right now. So say what you want to say.
As you can well imagine, there are many, many people interested in such research.
Yeah, kind of the things that Paul was talking about. There's you guys have probably heard of them, a laser ring gyro. Basically, you have a coil of fiber optics. You have a laser with a beam splitter. You send laser pulse down, opposite ends of the thing, and if you move the ring, it's like a Doppler shift, where you're either increasing or decreasing the frequency. And
boy, the speed of light just ain't what it used to be.
I guess, yeah.
I remember when it was so fast that it was unfathomable. Now, okay, you got a 3 gigahertz computer there sitting in front of you, so it can do an 80-point floating calculation in the time it takes light to travel 4 inches. So get those memory chips in close, boys.
Well, it's kind of like the James Webb telescope. You can see what happened billions of years ago, because it's taken that long for light to get from that end of the galaxy to us. So.
Okay.
I guess you're right. It's just not that fast anymore.
I keep being called away here, and I need to go make a phone call. I'm still in the midst of all that.
Okay.
Medicare. I leave you with that word. Doug knows that, of which I speak.
Yeah. I can tell you this, though. Without it, you'd be much worse off.
Oh, no question. It's just, I'm trying to find out what coverage Mom's Medicare Advantage plan has. And it turns out that's not an easy thing to do.
No.
And ultimately, there's a 199-page book that describes, and you go through and you say, well, I think paragraph 135 stroke B may apply to, it's just,
yeah.
All right, that's enough.
Okay.
Get yourself a medical, terminology dictionary, because you're probably going to need one.
Y'all take care.
All right, guys. I'm going to, Carl, who couldn't be here tonight, had an article that he wanted me to share with everybody. So I'm going to share it. It is an extremely interesting article, and I'll put a link in the chat, but I want to show it to you guys so you can see what it is. So let's see.
That's okay. I got a short parent story. My parents wanted to move into, I don't know if you want to call it assisted living or not. They basically would come in, do they provide food or meals. They would come in and do cleaning, that kind of stuff, and they pretty much had a vegan diet. And my stepdad is diabetic, and so they go there, and it's like none of the food is vegan. It's like way too much sugar for both of them. They put their house on the market. They weren't getting offers for what they wanted to sell it for. And like I said, they didn't like the food at this place. It's like, okay, well, wouldn't you check that out before you get there or move there? And so they moved back into their house now. So
Well, at least they didn't sell it and then didn't have no place to go.
oh yeah, well the place they would go would be here. So
You were glad they didn't sell their house.
yep.
Okay, this article here is the ancient technology keeping space alive, and it discusses the different space missions that are out there that have been out there for 20, 30 years.
Oh, Voyager.
And,
Yeah.
and 46 years, and it talks about some of the hoops and things that they've had to do to keep things going. So like in this one here, the batteries were dying, and I knew that we had to rotate one more time. That would be it. At that point, I was a bit pessimistic. So, eventually even though they were only getting intermittent communication, they were able to get it under control. And that's, after an hour they did it. And then here's another one. They found the original software was on a part of the onboard navigation system, was running on a Windows 98 PC that no one could find the password to. And apparently they had to tear into the actual unit with bolt cutters to get to the hard drives. Whole bunch of stuff here. So it's a very interesting article. Carl saw it. He wanted us to take a look at it. I'm going to put the link in chat.
I'm surprised there wasn't a big cigarette, filled ashtray on that console there,
Yeah. So anyway, there's that. Now, let's see. Oh, I want it now with respect to what was being talked to by Paul. Let me see if I can find it. Okay, here's one. This is an article by DF Robot. I have put the link in, and they talk about the different types, if you don't know anything about it. And here is the optical phased array and here's a couple of companies that are talking about it. So anyway, and I don't know what this flooded light array. I've never heard of that one. So, but anyway, that's cool.
Yeah, I read that page. It's good.
Yeah. Here's another mini laser distance rangefinder. This is 4 meters, I2C, waterproof, 1290. Now, obviously, this is just a point, but and it has the disadvantage that there isn't. You have to use the default I2C address, so you only get one of these. But anyway, it's still they do have a very nice wiki on this that's worth taking a look at. And I wanted
that 4 meter indoors or outdoors?
The good question.
Probably.
I would assume indoors. All right, but okay. Here's why I'm a little confused. It's waterproof. So.
It's 4 meters underwater. Cool.
I don't think so, but it might be outside. I don't know. There is the the LiDAR company that makes the little spinning LiDARs, they have come up with one now, and it's on sale for about $375, and they're claiming 80K lux, which would be a nice autumn day for us, but not a summer day. And I'm trying to find, okay, and here's STM's newest distance sensor. It's the VL53L7CX, and they're talking about a field of view of 90 degrees. And so you have 90 degrees and multiple regions in that. It's a 64 zone 8x8 array, and it has a maximum range of 350 centimeters, so 3.5 meters. Anyway, so this is their newest in line. It's supposed to be, you can get their development board for 33. I don't know what. Oh, it looks like the unit itself is 891. So I wouldn't be surprised if this shows up at one of our Adafruit / Poland people pretty soon. So that's something worth looking at. Okay. All right. I think those were main things that I wanted to share with people. I am. Well, wait a minute. Yeah. Give me a second here. I am looking at. My fall robot, and I purchased. I was listening to Scott the other day, and I guess because who can resist a new IMU? And I didn't get the one he got, but that's not it. But I did get the same thing from the same company, which is WIT. I don't know why is it back. I guess it's because we're looking at it. So I got their 902B chip, and I'm really. I'll tell you what I was really interested in. I was really interested. They claim that you can input your GPS into it, and I wanted to see if I could get my GPS to feed into it. Here's what the little chip looks like. I can get it out.
So you wanted to make a dead reckoning system, maybe?
Well, these WIT ones do have a Kalman filter in them, so they're. I don't know if they're better or worse than B&O 055, but here is what the. I don't know if I can get it in focus. Here's what the little chip, and they do have. This is the one that does have the pin so that you can connect a GPS to. And you recall that little GPS module that I had last week or a couple weeks ago? The one that's who I'm going to try and use it with. So we'll see. And I'm optimistic, but we'll see. And so that's where I'm going. Here are the wheels I'm hoping to use.
Make this sketch and select that. I'm going to cut all the way through. See how well that works for us.
I ended up with some of these. These are off of I think a baby carriage. They're 8 inches and they're very smooth. You can see they're very smooth. So so the trick would be if I can get these to be very light. Either that or end up having to put new, replace them with other 8-inch wheels. But
which outdoor platform
here.
This one's going to be one that I've constructed. Now, I've got, like I say, I've got my laser, I got my little router thingy going now. I'm feeling comfortable that I might be able to come up with something. So, we'll see. Or I might use that little tank-driven Jeep as a software study. Because that,
That $12 LiDAR module that you pointed us to, do you know what its operating principle is? Because there's nothing on the wiki that says
no, I
what
don't.
kind of a sensor it is.
Yeah. And if you look at it, it's not the fastest sensor in the world. Okay, so I don't know.
May do averaging then.
Yeah, I don't know what they're doing on that one.
The magic is not revealed.
Yeah, it's been epoxied into the waterproof case.
But they say it's the best things in sliced bread.
Yeah. Well, yeah. That well, the idea of the ones that are the much more expensive sensors is that I don't think right now that I would have the time to troubleshoot the software to get them to work properly. But a one-shot, essentially a LiDAR ultrasonic that doesn't get drowned out by wind noise and doesn't, has other problems. It might be what I need. We'll see. I have plenty of LiDARs that I can try, but I wasn't really happy last year when I tried the micro mini. Who makes that one? Benawiki. Yeah, that did not work for me well. So I was disappointed because my test, when I did it statically, it worked really well. But on the I don't know if it was because 5 volts versus 3 volts or what, but it struggled. Anyway, so that's all I wanted to cover. So I guess, does anybody else want to be on the talk, or do we want to go to open mic? How about you, Harold? You haven't said anything.
Well, I haven't said a whole lot. All I can really say is, what did I do with it? Oh, come on! It was going to be funny. Well, maybe not funny. Really? Oh, here it is. Guess what I've been doing?
Whoa! That looks like laser cutting.
It is, and this is on a longer Ray 5. It's a 10-watt laser.
Yeah.
It comes highly recommended as of a year ago, and it came cheap. I say cheap. I got the 10-watt laser. This is a basswood 1/4 inch. In fact, it cuts better than I thought it was going to cut. I got that. The grate that sits on it, the air assist, and a cover to go on top of it for right around $500 total.
Yeah, did you get glasses, or when you say cover?
Well, it's got glasses. It comes with a full set of stuff.
Yeah.
But I ordered the cover as well to stick over top of it. It's got a dryer hookup, like a dryer tube hookup, so I can vent noise to the outside.
Yeah. Yeah, that's good.
Put the environment instead of myself, that kind of thing. You know how we work. So
yeah. Well, that's cool. That's really
that's
cool.
What I've been playing on. In fact, what I've been doing this entire time is that it may be hard to see. My bright lights are extra bright today. I have one of these little laser pointer things.
Yeah.
So I saw somebody online mount one of them on their laser and then set up light burn, which I did buy that as well, so I can put this as a point on the thing and tell it to go, and it knows the offset of the laser, so then it knows where it wants to cut. I'm used to 3D printers where I know exactly where that plastic is going to at least start. I may not know where it's going to finish, but I know where it's going to start, because plastic don't always go where you want it to go. And so I've been designing me up a piece of plastic kind of thing where I can slip one of these inside with a coin cell and then slip it on top get it where I want it to go, set the 0 point, and then lift this thing off. Or if it's on there good enough, it just laid on there the entire time. But I'm afraid of because it's covering up some of the fins on the laser of getting that thing too hot. I know there's not an awful lot of heat, but I also know that laser, solid state laser, is also a consumable, and the hotter things get, the faster it gets consumed generally. So,
Yeah.
so
That's almost all laser cutters have that problem.
yeah.
Hey Harold, if
Yeah.
it, I don't know how familiar you are with Lightburn, but a very nice feature that they have in it. Okay, they have what they call frame.
Yes, yes. I've been using the frame thing, and my old eyes is not used to between the cover that's on side of it, on the inside of it, and the stuff, and it goes around pretty quick. It says, "Okay, I'm done." I'm like, "Okay, you need to do that like 20 times before I get the piece where I want it."
Well, you can slow that speed down.
So
You can
yeah.
slow the speed
I'm
down.
gonna tell you, I am brand new using the thing. The fact that I was able to find this tool and get this out of it, I was like jumping around,
Yeah.
almost.
Well, I'm real impressed with the cut you got there. That's really nice.
See if I could get a little over the
Because
top.
with my 30 watts CO2, I can do a little better than a quarter, but not too much better than a quarter.
Yeah, I've got a whole bunch of stuff in the other room to play on, like keychains and little leather things and little key fobs, and I even have a bunch of the stainless steel anodized or painted business card level things. I figured I'd try to make me some business cards with a QR code on them and be like, I don't know, thinking I'm cool or something. But all
can you move your camera to show it to us, or is it?
Not really. I mean, I can try. That's Mr. Big Head there. You see the saxophone and the coat and the dice. Well, it's behind all that. So,
Okay. Oh, so it's behind that. Okay, closer to your garage door.
it goes through the garage door, and yes, you're seeing more than my wife ever wanted you to see of my garage. So, the other thing that I did is, if you go to my YouTube or my Twitch account, I've got a brand new intro video that I got out this week, trying to, like, I don't know, pump up the volume, something, make it nice, whatever. Go check it out, go look at it, or don't,
Okay.
Yes, babies? Okay, babies. Yeah, this is nobody important, just the grumpy old man group. Yeah. Yeah, exactly. So, anyway, that's I intend on that thing does have Wi-Fi on it, although it's not. You can't. Lightburn does not know how to send to it because it doesn't know how to receive that. But I can send a file to it, and I can't hit the go button on the file. Now, knowing what I know now, I can't really do that a whole lot, but I can certainly monitor the thing, because I'm going to probably put that upstairs where it's more next to exhaust to the outside world when I get things kind of dialed into it, and just let it go. And it's got I call it a flash sensor on it, but basically it's just an IR receiver. And if it sees something really bright like the sun, they're expecting it's a fire, and it'll shut the whole thing down. So it's got a few safety features in it, right? So, so I think I got a pretty good deal on how it works, and I think it's going to be fun. And there's got a whole bunch of things that I got to learn on this thing. And you might be asking, Harold, why don't you get one? Well, just because, I wanted one, and then there's all kinds of things. I think we'll make the wife has got some buy-in on this too, with earrings and Christmas gifts and ornaments and God only knows what else.
Yeah.
You better include her.
But I did, and I made her watch a couple of videos where I saw somebody making their own earrings with the resin inlays like they're stained glass or something. And I got total buy-in on all that, so I'm doing like that. So I've learned. I haven't learned much, but I have learned. So
Sneaky.
Yeah, well, I will say that I've seen those new laser modules, and they really are nice.
Yeah, the only thing these things won't do, near as I can tell, is if I have to cut metal, I mean, I can
Oh,
etch
yeah.
lots of stuff, but if I got to cut metal, I got to go CO2. These things. I
No,
mean,
well, you can't
You're
afford
not going to cut metal.
metal
You're
with.
not going to,
You
even
gotta
with a
you gotta
60
go to
watt, you're
fiber.
not going to cut metal.
got
Yeah.
no plasma.
No, you're
Okay.
gonna have to go with plasma cutters or
Well,
You
fiber
got to get
optic.
to
The
see,
fiber optic
1,000
ones.
watts to
See,
get
Yeah.
I'm
metal cutting.
still learning. That's what I'm saying. I'm still learning. So,
Yeah.
what is there? Something else I needed? What was it?
Yeah, that's out of the
Oh,
hobbyist price range, I think.
I've learned. You know how they're getting these huge wattage label in these diode lasers, right?
Yeah, they're
They've got a
stacking
series
them.
of mirrors, and they're
Multiple
just stacking up. You know, the
Yeah.
smaller ones, and they're doing a collective and pointing down. And I'm like, okay, I guess that's one way to do that. And so mine says it's 10 watts, and it does a pretty good cut, as far as I know. And we'll see. There's a 20 watt upgrade, and I saw something the other day. There's an 80 watt thing going on, and I'm like, I don't know about all that, man. That's a lot of juice to be sabbing. I'm gonna, yeah.
Hey, Harold, you know, more obviously the higher the power, the more diodes they've got stacked. The question I would have is, what happens when one of them fails? Does the whole module go bad?
I bet the whole module goes down. Well, the way I've seen the side views is they've got angled glass where they're doing this number.
Okay.
So if one of them were to go away, I think you would just lose
Power.
Power.
Okay.
If just one will go away. And eventually, somebody was saying they've been printing almost nonstop with theirs for almost a year, and it's lost about. They did another one to cut test, compared it from a year, because I've been printing like a dog all year long. You know, held up 2 cut tests, and it lost about 20% on the power, and which is, I don't know if it's to be expected or not, but according to the specs, these things are rated somewhere between 10 and 20,000 hours of usage. And so you get a wide range of MTBF on that. So
yeah, well, I'd also wonder, how do you clean the lens on those?
I don't know.
You know, I mean, that might be, especially if you let it get smoked up once or twice. You know what I mean?
I did get the air assist from the very beginning. I've not used this laser without air assist on it. Yep. So hopefully that'll help some of that smoky stuff going on, because other things, and we'll see what happens.
Well, that's great. I'm glad to see people get new tools.
And I think I said this before, because I played with it just a little bit at the CB01, the little bitty one I was playing with. The light burn is just spend the money.
Yeah, I agree with you. Hey, Ben, brother, I agree.
Just spend it, because there's just no two ways about it. Because I tried to go cheap, and it was sadness.
Well, light burn isn't that expensive.
No, it was like $60, and I got
it's a lifetime, you know.
And 3 installations, and I can always say once I get to 3, I can go in and say this one I'm not using anymore, deactivate it and activate it again somewhere else.
Yeah.
So that's pretty nice.
Yeah, it's a great guy. Really had. Let me put it this way: it's a user-friendly model. I don't know if he's making as much money as he could, but it's very user-friendly.
I know it does a lot. Like that cut test I did, it took me a little while to figure out what all the words meant. But I would if I had to draw that myself, I'd never done it.
Yeah.
You know, so it's just it's a nicety.
Well, you know, you don't have to. You can use, if you're familiar with Inkscape or Illustrator, you can do it there and just import it.
Still, I would still have to do it myself, and I've got to go figure out power settings and all those sorts of things.
Oh, no, okay, you were talking about that specific job. I know, I was talking about if you wanted to, Lightburn is very flexible.
Yeah, you can import all kinds of stuff. In fact, I've got something to do for work that I did a 3D print to get the job done that they wanted. Then it occurred to me that Improving has this splat looking thing right here, and they're going to put that splat on a few different things. And so I modeled them up something where you could set it over the top of the Jenga thing and spray, so you get the splat coming through. The deal, I'm going, well, that's going to be messy. You got to do more than 1 or 2 of those things. It's going to be a problem. How about we make a stamp, like old school rubber stamp stuff? And so I've got enough tools over here, and I'm betting my laser's strong enough to cut that
Should
rubber
be.
stamp stuff
Should
and,
be.
and just stick. And then once I get it cut out sort of away, just mount that on a stamp and then let them go stamp crazy. You know,
Yeah, the K40, you know, it was originally designed as a rubber stamp maker.
was it
Yeah.
cool, man? And so I don't know. I got into all this stuff, and of course I could upgrade all the stuff just like all the 3D printer stuff, and so there's some coolness about that.
That cut that you did, was that like a gradient cut? You know, did it
Yes.
increase time or
Yeah,
laser power or?
So here's a
Into-
couple things to see if I can. Here, let me go around the other side. You know, that's where the Buffalo girls are. They're around the outside. So there's a song reference. So this is a cut test, and this is a etch test. So I go from 10% to 100%, and here it goes from 100 millimeters a minute to 1,000 millimeters a minute. I looked up the specs on this thing, and about 1,000 is about the fastest you're ever going to cut with this thing for a cut. And so I'm like, okay, cool. It generated that for me. I got it on my board. Then I went and generated the edge test. And this goes from 5%, which almost nothing was there, to 50 on it. And you can set all these parameters. This is me just goofing around, and I didn't know what I was doing. Well, I still don't know. And I went from 1,000 millimeters a minute to 6,000 millimeters a minute, because that was also on the spec sheet I looked up for the thing. And I got some pretty decent stuff. And in fact, if you look at the back, right at the edge of that cut, I did 4 passes. This is a little over baked, as you can see, but I did 4 passes, and it's almost got another whole row of cut things there out of 4 passes. Even at this lowest level, I was even coming through a little bit, at the very little bit, even at its lowest level, as if I was going slow enough. And this thing here, I like I say again, first time I've tried this stuff, so don't know what I'm doing really. If you run your finger over this, like, of course there's nothing here, but as it gets darker, it not only is getting darker, it's also getting deeper. So the time you get to this over here, that's like a millimeter and a half, maybe 2 millimeters of inset that it just burned off as it was going.
Okay, so the one on the right is that one.
Mm-hmm.
So that one is a raster where it's going back and forth.
It's a raster, yeah.
And the other one is a cut, a vector cut.
Yep, this is a cut, and this is I think it's labeled as a fill when I was doing it inside Blackburn.
Okay. Over on the cut, do you have any that are kind of light brown, like just barely, discolored?
If you look like just barely discolored.
No, I'm talking about ones that were successfully cut.
Oh, they were cut all the way through? Yeah, these at the very top here.
Yeah.
They're not anywhere near, as you can see here, how dark this got.
Yeah, you don't want that.
You don't want that. But if you look at these top 2 right here, even down to that one right over here, all those are pretty good.
Okay.
And in fact, that one right there, if I push on it a little bit, would probably come out.
Mm-hmm.
Yeah. See, that just came right out. And well, I had to push on a little bit. I lost a little bit of wood there, but but it's something you need to play with. So these top 3 here is probably what if I was going to cut something right now and do this, I would probably go with either 500 or 600, one of these 2 here, between 70 and 80%.
Do they give you any, like, for example, on the CO2, they tell you not to really run it 100% laser power?
No, I haven't seen that. I'm going to take that back. As long as I don't care about speed, if you'll look at this 30% at 200 millimeters a minute, if you'll look at that, which is right here. Yeah. There's very little anything, and also the one next to it, very little. And I'm running at between 30 and 40% at 300 to 400 millimeters a minute. And that's probably a better way to go, as long as I don't care that I'm fast.
Yeah.
Of course, I've been waiting a while. I can wait a little longer.
Well, that's really neat. I mean, like I say, that it looks like it has good capability.
Yeah, it's got a lot of good reviews. Here's the deal: they're just starting to advertise and push their newest model. And this is last year's model. I got a discount. I'm just saying.
Oh wow. What's
Hey,
and it's,
is the laser or that 10-watt rating, is that, optical output power, or is that
I, I,
input power
I
to
think that's
the
input. I
laser?
think that's input. I think it's
Oh,
input.
it is? Okay.
yeah,
I don't think it's output.
yeah,
In fact,
and
No, I think that's output power on that unit.
you think
yeah,
it? You think
yeah.
it is?
Yeah, I think it is. I've seen
Okay.
others that that do the bait and switch, and
Yeah.
but if it's the unit I think you're using, I didn't hear which one you were doing, but if they're the ones who also have the 20-watt that's just
Yep.
come out, that you can't actually buy the machine with the 20-watt, but you can get a replacement 20-watt module for it.
Yeah.
That's that company, that's the output power.
Okay, then I stand corrected. I wasn't sure what I was going to get honestly, but I saw a lot of reviews on the. It's the longer Ray 5 is the one I've got. They've got a B something or another out now. Coming, they're pushing, but I saw a lot of good reviews on it. I put it on my wish list sort of thing, waiting to get a my yearly bonus and yearly thing and all that kind of stuff shows up. You know how that works, and then when it came time to get it, the only thing I didn't get that I wanted was the rotary tool, and they only had them in Europe, and they for some reason weren't going to ship them to the U.S. So I figured the $80 for the rotary tool, I got plenty to play with, and that rotary tool would just be sitting anyway until I got around to doing something. So when I want it, it's there to get it, and it looks like, near as I can tell, the level of laser cutter that I've got going on here, whether it's the X tool or whether it's the Comgro or Sculpet, or there's a number of them right around in this area that they all use the same pieces and parts and connectors and all of that stuff, near as I can tell. So I figure I'll be able to find one when I'm getting ready for it, if I ever do, which I probably will, but that kind of stuff.
Are you using what do they call it? It looks like a screen, but it's about a half-inch thick.
Yes.
Yeah.
Yes, I ordered one of those too. So
Yeah.
for the cutting, and it's the metal gyroid wavy thing. So
Yeah. That really helps on. It keeps you from getting backsplash on the backside.
I got you. I ordered everything that I could that I thought. Like I said, the only thing that I didn't get was I got the air assist. I got the screen, a cover so that if the wife doesn't have glasses on if she walks to the room, and all those sorts of things, trying to be safe, because this I mean, after I saw what it did to this, I mean, this ain't playing around.
Yeah.
I mean,
Well,
you could get in the world of hurt real fast. And
down at the makerspace, when they first started up with their lasers, they had a couple people put holes through their fingers.
really,
Yeah.
Really?
Yeah.
well, those things down there in Makerspace are in the 120 watt range, if I
Yeah.
remember correctly.
Some of them. Yeah.
Dude, I see what 10 watts does. I'm 100, 120 watts got to be some serious piece of stuff going on.
Well, let me ask you this, Harold, because like you said, there's the biggest problem I have with mine, and I've got a solution for it. But if you want, I'm just kind of letting you know, and it sounds like you're doing it. Is the smoke. You got to get rid of the smoke, and you got to make it safe for people to walk in the room unexpectedly.
Yeah. I got dogs and cats, and there's no telling when they're going to come in and go and do.
Yeah.
So, I mean, they got eyeballs too, same as anything else. So.
Yeah. So, but in the end, the worst one will be the smoke. Once you get it enclosed, getting it properly vented out, because burnt wood really doesn't smell very good.
Yeah, well,
I'm sure it's
the
not
wife
great doing it.
let's just say the wife has thought the garage was on fire several times already.
Ooh.
Yeah, and plexiglass is even worse. That really stinks.
Yeah, I've heard a couple other things too. Things like ABS and PVC and a few of those things. You just don't want to cut it all because they emit like chlorine gas or something. And I'm like, oh yeah, that's great. That's cool.
Anything that has, I think you can. Anything that cuts has chlorine, you don't want to cut. And that means Lexan too, by the way. So when you don't spend the extra money to buy you a nice piece of Lexan and bring it home, because that ain't going to work. And you don't want to do styrene because it doesn't really cut. It kind of melts.
Melt it.
Yeah, and there's I think with ABS, I don't think there's any chemical reason why you can't do it, but it doesn't cut well.
It doesn't cut well.
Hmm.
I was thinking about one of the things I would like to do, and this is harkens back to Murray, but Murray ain't been here in a while.
Yeah.
And he was a big fan of that Delrin stuff, and I'm wondering how well that cuts with the laser.
Yeah,
And
I don't know.
it-
I haven't ever cut it.
I'll find some around here, and we'll try cutting it here for too long, I guess,
Hmm.
and see how well that cuts. Because I mean, there's been a lot of people that are really big fans of that because it's lightweight, it's strong, you know, it mills easy. As far as when I was seeing with other things, I'm like, well, if it mills easy like that, maybe I can cut some parts and pieces and things out of it.
Hmm.
Those sorts of
Yeah, and I think, I don't know. I've never cut nylon, but nylon might be possible too.
Okay.
But I don't
Okay.
know. I haven't done it, so I can't really say.
Apparently, there's some materials like cloth and that kind of stuff, and a lot of the cosplayers are starting to use this on that EVA foam they use to make all their
Yeah.
costumes out of. They say it cuts really good.
Mhm.
And there's also, because I was talking to somebody, the safety floor mats at Harbor Freight, those
Yeah.
half-inch, three-quarter-inch thick
Yeah.
safety floor mats. Apparently, they cut really nice and are really great to work with if you need to cut them out to put them into something to build up, the Pelican box type stuff full of things.
Yeah.
Apparently, I don't know. That's what I was talking to a guy out in Vegas about
Yeah.
that on my Twitch
Yeah.
stream.
I've cut that, and it's not bad. There's let's see. I was going to tell you. Oh, foam board. The little foam board you can get at. Now the problem with foam board is the foam will melt. So you'll have a paper lip with a recessed foam layer.
Okay.
Okay, but if you do it right, you can cut it, and it can be very nice for like wedding decorations and stuff like that. I use it for my daughter, so we
Yeah,
cut a lot of
I've
stuff.
got no doubt the wife, will have ideas of me to do things to do on this.
Yeah, just remember chlorine bad.
Chlorine bad, yes.
Yeah, I don't know if it's related to chlorine content, but I thought anything clear was okay, but like translucent or opaque, not okay.
Well, I was doing some reading, and
I've
they're
done
telling me clear acrylic on this laser is not going to cut very well. I can't impart enough energy into it to
Oh,
make the cut. That's what they said. Now I don't know for sure, but that's what I've been reading. Now,
That's
colored
what
acrylic,
yeah.
they say you can cut that all day long.
What I was going to tell you was that the darker the material, usually the easier it cuts.
Hmm.
Okay.
Cool.
But I mean, like, if you have like a black or dark green or something like that, it'll cut pretty good. Clear, I'm using a CO2 laser, so it's different. But
Yeah.
I have no problem cutting clear
Good.
acrylic.
Little bit different frequency of light and all those
Yeah.
other kind of things
Yeah.
that go into that, right?
yeah.
There's again, this is intriguing in all kinds of ways.
You're gonna have fun.
Basically, with the 3D printer, there's all kinds of different things you can mess with, and then it's different things, and you want to do different stuff with this, because much like the 3D printer, there's going to be things on the 3D printer that I can make that I can never ever really manufacture or injection mold and those sorts of things, and there's going to be things I believe I'm going to want to make on the laser cutter that the 3D printer just can't make a strong enough one of.
Yeah.
That sort of thing. That's kind of my thoughts right now.
Yeah. Well, here's something too for robot material. One of the best ones to use is hardboard.
Hardboard,
Yeah. There's another name for it. What do they call it? Masonite.
or
Yeah.
sometimes they call it underlayment or something like
Yeah.
that.
Yeah.
In the Home Depot store.
Yeah. Yeah. And if you're going to do, plywood, underlayment, Leyland underlayment cut
Okay.
is real cheap. real cheap and cuts well. You know, it might not be as pretty as, you know, your basswood, but
Yeah.
but it's
You talking about
Oh,
OSB?
I just picked up what was to me.
Board?
Though.
well, I'm sorry.
Underlayment, is that OSB?
No.
No,
Oh.
it's like plywood, but it's kind of it's I want to say it's Leyland.
Luann, maybe.
Anyway, but it's and it's all going to be metric, so you know they might
Oh.
tell you it's quarter inch, but you know it's not really quarter inch.
6 millimeters.
Yeah, well, if you're lucky, you know, and same thing with 3 millimeter, you know, 1/8 inch stuff. But yeah, you like I say, that you can. It's really but for just general robot stuff, I find that the hardboard or masonite is surprisingly good. It's a little bit hard to cut all the way through because you can't hardly get any double tempered stuff. If you can find a source of double tempered masonite,
Yeah.
you know, latch on to it because that's good stuff.
Because I mean, if you think about it, that stuff is probably not going to warp, and it's usually pretty flat.
Yeah.
And you know, I could see, and it's certainly easy to drill into, and all those other kind of things to make holes and mounting spots.
Yeah.
I could see how that could be a good thing.
Yeah.
Is it that rigid though, or is it fairly?
It's pretty.
flexible?
It's pretty rigid. I mean, for the size of robots we generally build.
Yeah.
Okay, you know, and like I say, you can use plywood if you know. Plywood is a little tougher to cut, but not too tough. But so it's just you'll have fun just learning all that stuff.
Of course, if you use plywood, you're going to be, you know, call it a woody, you know.
Oh.
Yeah.
Well, I'm always on. In fact, I did another one today. Somebody for last week has had an Ender 3 Pro, no Ender 3 just normal, you know, up for $100. Obviously, they don't know what they got, and because they go, well, it needs a nozzle soon. I'm like, okay, you had it up there for a week, no one's taken it. I'll offer you $50 for it, because you know, if you think about it, it's got 4 stepper motors on that. That right there is $50 right there. If I had to go buy them new, you know, pretty close. And so I get a power supply and some other stuff and a bunch of 2040 and 2020 and that kind of thing. And I think I can build a lot of robots out of some $50 worth of parts and a bunch of 2020 extruded aluminum.
Yeah.
You know, I think that can go pretty quick. I think that can go pretty stiff. So
Yeah.
I say a bunch of robots.
My ongoing project, and the material is going to come in this Wednesday, is I'm making an enclosure for my little Comgrove CNC router.
You're right.
Yeah, so it's gonna be made with 2020 extrusions, and I'm.
So did you get that 500 watt motor working?
Oh yeah. I thought I showed to everybody last week, but
Last I saw, I don't know if I was here all, but last I saw is that you got into a ground loop on a thing, and that was a problem. That's the last I saw of it. So.
Yeah, well, I got that taken care of. You know, here's some examples of. I don't know if you can see it, but those are halfway through this 3 mil aluminum, and this one is a really nice engraving.
Oh, look at that! That's
Yeah.
nice.
And but I'm going to. I've done some speed matrix, just like yours, you know, speed power matrix. Okay, I did it speed depth of cut, and I actually found that I was being pretty conservative, and I could go up a little bit. So I'm pretty happy with that. Now, like I say, I'm not so happy having to stand around vacuuming up the glitter. So I've got this upgrade that I got is I got one of those things that, let's see if I can get it off here. one of these things that goes on the bottom
Oh yeah.
and picks it up. This is a really nice one by Jinmitsu. Very highly rated. Works with magnets. So
Oh, look at that. Doing all
there's a
sexual
piece
stuff.
that's mounted on the that I'm not showing, that's mounted on a router. So you take up these pieces off. You can work with set the bit.
Yeah.
And then you clip this back in, and then you clip this back in, and it works really well. So anyway, we're going to see how that goes.
Well, I do hope it goes well.
Yeah, if I can get the enclosure built the way I'm thinking it's going to be, and I'm refurbishing an old wet vac that I have out. It turned out it was my dad, so that's how old this sucker is. And
Oh, look at
but it's got a
coming in with the hot chat.
yeah, but it has a very low. It actually only makes 80 dB as opposed to the 96 dB of my other one. So it's not what I'd call quiet, but it's at least it's not as it is horrible. We'll see how it goes. I'll tell you next Tuesday.
Hold on. So I actually can give you a link to
Hey, thanks for that link on the tempered hardboard.
I don't know why I didn't go ahead and do this. So this is the laser cutter I got. For all of you that want to play along on the home game, so to speak. And I got the 10-watt version of it. And,
Yeah, it seems like you look at the efficiency of a lot of those, it's 50% or so,
yeah.
if that, so yeah, it's 10 watts, but okay, optical power is actually 5.
Yeah, that's why I was hesitating, because I'd forgotten. I'd looked it up. And I spent money on it. I'm going to run with what I got. Dance with the one who brung you, so to speak. And whatever that is whatever that is. And the cheerleader in me, the high eye and the disc profile, it deprioritized that bit of information. So I couldn't tell you.
Yeah.
But there's lots on YouTube. I don't know. A lot of people got much reviews. They were sent this to do it, so I don't know if they gave a good review because they were sent the thing. But there's been a lot of folks that say, "Hey, man, this is just a good laser, beginner kind of thing," and they got a discount, so I'll take a discount. It's certainly beaten the etcher that I got from Creality. That as much fun as that may or may not be in the future, I haven't given it. Still got it. Don't know what I'll do with it. Maybe something. I don't know. Actually, what I see is building a little case for that and taking it on conventions and something, and engraving people's little things here and there for folks. Back of their phones, whatever, keychains, whatever, on the thing. Go pretty quickly and easy to transport. But I don't know if I'll do that either. I don't know. I know I'm gonna burn a lot of wood though. Got that pretty sure of that.
Mm-hmm.
Probably give you a heck of a burn, but probably wouldn't burn through your finger.
No, that little bitty one, it's 1.6 watts is what it puts out, and it certainly does a good enough job on the basswood for etching, and you just forget about cutting anything really.
Mm-hmm. Yeah, this I think the innovation that's happened in the last year or two is the stacking lasers, which is really helping things out.
Yeah. Yeah, I'll take that. Take a bit of that. And again, it's one thing with the 3D printers. You're talking safety, Doug. You're talking 3D printers and all that kind of stuff. There's some danger there with heat and some other stuff and burning your house down and a few things like that if you want to go that far. But with this thing, I mean, this could put an eye out from across the room. So, you know, I don't want to play with all that.
Yeah.
I mean, I got a table saw over here too, and the very second you disrespect a table saw is the second you lose a thumb or a finger or something else. You know, you just, yeah, exactly. Exactly.
Yeah, table saw, and I have an old one, so you know there's no safety on it at all. So yeah, you got to be. You never can be sloppy.
You were always showing it the respect it deserves.
Yeah.
That's all there is to it.
Did you ever see the? There's a system that they have. I don't know how it works, but it seems like if it touches your flesh.
Oh, the saw stop. Yeah, the saw stop. Yeah. So I forget exactly how it works, but I think it's off capacitance. Okay, and so, or stop. Get the order there, but and the guy actually did it. The guy that owns the thing, invented it, did it with his own finger.
Yep.
It left a little bitty mark right on the side there, but I'm like, I'm not doing that. They usually do it with a hot dog or something, just so they show it, right? And how it works is that it's based on capacitance, and underneath the saw, inside the saw cabinet itself, they have this big thick block of aluminum that's honeycombed up, and as soon as that capacitance changes by whatever voltage, micro voltage it is, there's a spring-loaded thing. It just lets go of it, and that thing just jams up into the saw as hard and fast as it can.
Yeah, it looks like it may do additional damage to your saw.
So when that happens, there's no resetting it and trying again.
It's
you
pretty.
got to get a whole new guts. I got to get all the new guts in there, and it's not cheap, but it's probably less expensive than a new finger. So, yeah, those are pretty. Those things are. Really
they use those at the Dallas Makerspace, and I think they've saved some fingers.
Oof.
Or at least they've had them go off. I don't know the details.
Again, I think it's capacitance. But it's it's really highly tuned to the saw that's in there. So any little change or whatever, the thing goes off.
Better to err on the right side than the wrong side, huh?
There's no doubt about that. No doubt about that. And I didn't even think I had anything to say. What the hell?
There you go.
Okay.
The other thing I started today, is Karim still here? Or has he left us already?
I think he's left.
He's left.
Karim, yeah.
Yesterday was my first TEALS class, TEALS. They've got me and a few other people coming in once a week to guide a bunch of high schoolers in computer science. In this case, we're teaching them Python. So it was kind of fun. It's draining, actually, because I was trying to find, not that I was going to make a mistake, but I wanted to keep my folks engaged, kids engaged, and I'm not sure that I know how to do that.
Yeah.
But I'm wearing my tie-dye lab coat, so, at least I'm thoughtful.
Yeah. Okay. Well, guys, I'm going to say this. It's. I didn't realize how late it was. It's 10:30.
I didn't know I had that much to say.
Yeah, I think we might probably ought to call it a day tonight. Or a night today, whatever. Anyway, so if nobody protests, then I'm saying let it go.
Yeah, there you go.
All right, guys, good to see you again.
This is awesome.
Nice to see everybody.
Awesome.
Thank you.
Yeah.